Welcome back again. Mastery Algebra 1. This is lesson 3.7b, a little bit more on absolute value equations and inequalities. This is absolutely less. Here we go. We need to answer the following questions and see if they're true or false. Okay, is the absolute value of 1 less than 2? Absolute value of 1 is less than 2. So that's true. Absolute value of 3 is 3. Is 3 less than 2? No, that's false. Absolute value of 1, negative 1. Negative 1 is 1, which is less than 2. That is true. And the absolute value of 0 is still 0, so that is true. Okay. What I want you to do for 2 and 3, circle the numbers in the set that can be substituted in for x to make the inequality true. So the absolute value of x is less than 2. And then in 3, do the same thing for the absolute value of y is less than or equal to 2. Go. Alright, let's see how you did. Remember, when we take anything and plug it in an inequality, we're looking at the distance away from 0. So it's going to be negatives to positives, and the positives will stay positive. So we need answers that are less than 2. So, for instance, negative 3 will change to 3. Nope, that will not work. 2.75 is still going to be greater than 2. Negative 2 is negative 2 becomes 2. Is 2 less than 2? And the answer is no. So the first one you should have had circled is negative 1.33. Negative 1 will be 1, which is also 0, 0.5, 1, and 1.99, because again 2 is not less than 2. So on 3, we are looking for less than or equal to. Well, we know these are already less than, so these answers you should still have circled. But because of the equal to, we now can throw in 2, and we can throw in negative 2. Okay. So absolute values with inequalities are just like the equalities that we just solved in 3.7a. Every absolute value inequality with less than or less than or equal to represents two inequalities combined with an and. Hence the symbol right here. This is a less than. There's another way you can look at it. So the absolute value of x less than 2 means x is less than 2 and x is greater than negative 2. So let's use these principles to get our equations. So 4, if we had the absolute value of x is less than or equal to 5. Okay, that means if we just take our original equation, remember we got the x absolute value by itself, we can say that x is less than or equal to 5. And now the one thing that we have to do is we need to flip the sign and then make the 5 negative. So our other equation is going to be x is greater than or equal to negative 5. So if we jump up to here, what this means when we have those x's, it means that x is less than 2 because the number is less than 2. The absolute value will always be less than 2. Okay. It means that x is greater than negative 2 because numbers greater than negative 2, the absolute value will be less than 2 still. So this helps us get our two equations. So on 5, absolute value is by itself, less than 250, so we stick with our x is less than 250. But to get the other equation with the negative, we are always going to be greater than the negative, so we have to flip the sign and make it negative 250. So we get x is less than 250 and x is greater than negative 250. Okay. Number 6, absolute value of x plus 3. That is by itself, so we can take our equation and we know that it means x plus 3 should be less than 5. So we're less than the positive. And we're going to have x plus 3, but we have to flip the sign. So now we're greater than, and we're greater than the negative 5. Then the question comes out on number 7. Well, what happens again if we have something on the outside of the absolute value? Well, we have to get the absolute value again by itself. So we're going to now add 1 to both sides. Okay. That's going to change our answer to the absolute value of 2x is less than or equal to 9 plus 1 is 10. Okay. Now that we have the absolute value by itself, our two equations, just take that original and put it down without the absolute value. So the absolute value of 2x is less than the positive, but with the absolute value becomes 2x, we have to flip the sign. So now we are greater than or equal to the negative. So this becomes 2x greater than or equal to negative 10. So skill 4 says, with absolute value inequalities, if we have the absolute value of y minus 2, which is less than or equal to 4, we have y minus 2 is less than or equal to 4, and y minus 2 is greater than or equal to 4. And then we treat it just like part A, where we're going to solve both equations the same way. We have to get y by itself by adding 2. So we get y is less than or equal to 6, and y is greater than or equal to negative 2. Now what we have to do is we have to graph this solution set. Okay? And two ways to write this. We have y is less than or equal to 6 and y is greater than or equal to 2. Or we know that we are greater than the negative but less than the positive part. Okay, so we can say that all the y's that are in between negative 2 and 6 inclusive with negative 2 and 6. So the graph, because negative 2 and 6 fall in this category, we put closed circles because negative 2 is included, and we put a closed circle there for 6, and then we shade everything in between. Okay. Because we know we have all the y's that are less than 6, all the y's that are less than 6 are this way, but we also need all the y's that are greater than negative. Let's practice. So number 8, we have the absolute value of 2x plus 5 is less than or equal to 5. Okay, the absolute value is by itself. So we know that one equation we should have is 2x plus 5 is less than or equal to 5. And the other side, we're going to take the 2x plus 5, but we have to flip the sign and make it negative. So our two equations, 2x plus 5 less than or equal to 5, and 2x plus 5 is greater than or equal to negative 5. Now we can solve both equations. We need to move the 5 over, so we're going to subtract 5. That gives us 2x is less than or equal to 0, and 2x is greater than or equal to negative 10. To get x by itself, we're going to have to divide by 2. And on the first equation, we get x is less than or equal to 0 divided by 2 is just 0. And x is greater than or equal to negative 5. Now remember another way that we can take this, because here is our solution set. We're going to be greater than this negative number, and 0 is the positive number, so we can actually write it as x less than or equal to on both sides. 0 is the higher number, negative 5 is the lower number. So you have two ways to write this. If we graph this, pick our graph, we know we have negative 5 is that lowest number, so I'm going to go one little less. So this is negative 6, negative 5, negative 4, 3 to 1. Okay. Because we have the equal to, we know that if we plug in negative 5 is equal to negative 5. So we can do a closed circle on negative 5. And we can do also a closed circle on 0. And we're going to shade all of the numbers that are less than 0 but greater than negative 5. So that is everything in between here. So what we're going to do is we're going to take one solution set that's not in the equation and one solution set that's in and check and see if we are correct. So let's just take this for the 1's going to be probably the easier on the outside, and then we can choose like negative 2. So the first checking, let's check the 1. So if x equals 1, so this should not be true. Absolute value of 2 times 1 plus 5 is less than or equal to 5. So it's the absolute value of 2 times 1 plus 5 is less than or equal to 5. So 2 times 1 is 2 plus 5 is 7. Absolute value of 7 is 7. Is 7 less than or equal to 5? And the answer is no. So that did not come out. If we check the other one, let's check negative 2. So if x equals negative 2, which is a true solution, so we go 2 times negative 2 plus 5, absolute value, that should be less than or equal to 5. Negative 4 plus 5. So we get 1, which is less than or equal to 5, and that works out. All right, go ahead and hit pause. I'm going to have you do 9 and 10. Check back in a couple minutes. Don't forget to graph and don't forget to check. Go. Alright, welcome back. A couple tricky ones. Number 9, absolute value is by itself. So the two equations right here, 4y minus 8 is less than 0 and 4y minus 8 is greater than 0. Adding 8 to both sides, dividing by 4, you get y is less than 2 and y is greater than 2. Over here on the graph, notice what I did. Because it's not an equal to, we cannot have 2, so I put an open circle, so there's non-inclusion. Okay, and I wanted all the y's that are less than 2, so that's 1, 0, and all the negatives. So we went this way. Okay. Then we also look at all the answers that are greater than 2, so that's 3, 4, 5, 6, and all the decimals and so forth this way. But because we say and, is there anything that's less than 2 that's also greater than 2? And the answer is no. So I plugged in both 2 and 4, and notice they did not work out. So this answer is no solution. Okay, 10, if we have the absolute value by itself, we have 2 minus y is less than or equal to 1, and 2 minus y is greater than or equal to 1, negative 1. Okay? Remember to flip the sign and make it negative. Okay? Both equations, we have to subtract 2, then we have to divide by that negative 1. Okay? And remember from a couple sections before, when we're multiplying by negatives or dividing by negatives, you have to flip the sign. So by doing that, that gives us this y is greater than or equal to 1 and y is less than or equal to 3, which we have all the y's over here that are between 1 and 3. So we had the closed circles on 1 and 3 and shaded everything in between. I checked 2 answers. 1, I checked 2, which should have been in there, and that worked out. This check mark. Okay, and then I checked 4, which was on the outside, and that checked out here. Okay, 11 and 12. A little bit more complicated, and 13. Because now we have something again on the outside. Okay, but it just applies just like lesson 3.7a, where we need to just get the absolute value part by itself. So if we divide by this 3 first, and we divide the other side by 3, we're going to get the absolute value of e minus 2 should be less than 3. Okay. Now that the absolute value is by itself, we can write our two equations. E minus 2 less than 3. So keep that original equation. Okay, less than, so it's an and then we say e minus 2. Again, do not change the signs that are inside the absolute value, but we have to flip the sign, make it greater than, and greater than the negative. Both equations we're going to add 2. Add 2. Add 2. Add 2. E is less than 5 and e is greater than negative 1. Can we have answers that are less than 5 but greater than 1? And the answer is yes. So we can also write this as e, less than signs. The bigger number is at 5, so we are less than that 5, but we are greater than negative 1. Okay. Graphing over here, we are open circle because it is not equal to. So an open circle on 5, an open circle on negative 1, and we're going to shade everything that's in between those two. So check an answer. Let's just, 0 is in there, so let's do e equals 0. Okay, so we're going to go 3 times the absolute value of 0 minus 2 should be less than 9. 3 times the absolute value of negative 2, so 3 times 2 is 6, which is less than 9, so that checks out. Okay, one that's not, let's do negative 4. So if e equals negative 4, we're going to go 3 times negative 4 minus 2, absolute value. 3 times absolute value of negative 6, which is 9. 6 times 3 is 18. Is 18 less than 9? The answer is no. 13. I'm going to skip 12. Don't forget to do 12. Okay. We'll hit pause in a second to check your answer, but let's skip to 13. Okay. Notice we have absolute value of 8 minus parentheses w minus 1 absolute value. Notice, is there anything on the outside of the absolute value on the left-hand side? The answer is no. So we can immediately jump to writing our two equations. So we're going to say that what's inside, 8 minus this w minus 1, is less than or equal to 9. And we're going to say that this 8 minus w minus 1, flip the sign and make the negative 9. Okay. Go back to really chapter 1 and 2, where we are getting rid of the parentheses by distribution. So we're going to make this by distributing the negative through, or taking the opposite of what's inside. We're going to make this 8 minus w plus 1 is less than 9, and 8 minus w plus 1 should be greater than or equal to negative 9. Okay. Before you start moving things across the inequality, combine like terms on the left-hand side. So 8 plus 1 gives us negative w plus 9, less than or equal to 9. And negative w plus 9 is greater than or equal to negative 9. Now we can subtract 9 on this side. We're going to get negative w less than or equal to 0, and negative w greater than or equal to negative 18. Okay. Notice we still haven't got w by itself. We need to divide by negative 1, divide by negative 1, divide by negative 1, divide by negative 1. By doing that, remember, dividing by negative, we need to, yes, flip the sign. So we're going to say w should be greater than or equal to just 0, and w should be less than or equal to 18. Can you have numbers that are greater than 0 but less than 18? And the answer is yes. So we can put our less than or equal to's, put 18 on top, 0 on the bottom, and we have our two ways that we can write this. Graphing. We have 0 way down here. Just put 9. We have 18. We know that they are closed circles. Closed circle on 0. And we're shading everything in between. All right, go ahead, hit pause. Go back to number 12. Try number 12. Check your answer. And we'll see you back here in about 1 minute. Go. All right, welcome back. Quickly, if you check 12, most of you hopefully would subtract the 4 over, and we get the absolute value of 3x is less than negative 12. Okay, hopefully you remembered the geometric definition of, and the algebraic definition of absolute value, the distance away from 0, or when we plug in answers, hopefully they become positive. Okay. If we rewrote our equations, we get 3x less than negative 12, and 3x is greater than 12. Okay. By dividing by 3, this answer, x is less than negative 4, and x is greater than 4. Well, if I tried to write it the other way, x is, greater than 4, switch this, and x is less than. Because of the and, we are looking for numbers that satisfy both equations. Well, if you look on my graph, okay, do we even have any numbers that are in both solutions? So if I picked negative 5, is negative 5 less than negative 4? And the answer is yes, but is it also greater than 4? And the answer is no. So anything that we plug on 1 will satisfy maybe the negative, but it will not satisfy the positive. So therefore, I checked 5, checked negative 5, they didn't work. So this answer should have been no solution. Phew! I know that was a toughie. Hey, congratulations. Do your best, forget the rest. Bye for now.